Welcome to NTM Lab's advanced video tutorial of the OrthoRead application. If you have not yet watched our basic tutorial, it is recommended that you do so to gain an understanding of the basic features of OrthoRead and how to segment fracture callus. In this video, I will be covering some of the more advanced features of OrthoRead, which include converting results to millimeters squared, operating multiple images, and an overview of some of the tools OrthoRead is equipped with. When we left off from the basic video tutorial, I mentioned that it is possible to convert pixel results to millimeters squared using a hardware feature of known dimension. Let's take a closer look. To begin, we can access the conversion options of OrthoRead by clicking the Units button. This will display a pop-down panel which contains these options. You will notice that OrthoRead allows for 3 options of conversion. Each option requires some input from the user. Let's use the Auto option as we know the diameter of one of the screws. To begin, we'll start by entering the known diameter in millimeters of the screw that we'll be using. Next, we'll select the Auto option. You'll notice that OrthoRead opened the original image for you instead of using the cropped image. This will give you full access to all the screws in the image. You will notice that the Auto button has been outlined in black and the text bolded. This is to signify that you are currently using the Auto option. The next step of the Auto process is to select a region of the screw of known diameter. You will notice that OrthoRead has displayed for you an image of the region of the screw as well as the detected diameter. You will also notice that OrthoRead has updated the results field to show a result in millimeters squared. Next, let's look at the line conversion option. The line conversion option operates in much the same way as the Auto option. However, instead of the user selecting a region of a screw of known diameter, the user draws a line between 2 points of known distance on the image. For example, 2 screw holes on a plate. Last, let's examine the PPI option. If the user knows the pixels per inch of the image, they can enter it and select the PPI option. OrthoRead then calculates the conversion factor accordingly and updates the results field to reflect the measurement in millimeters squared. Next, I would like to show you the use of multiple images in OrthoRead. If you have yet to watch the basic video tutorial, I recommend you do so, as I will be going through the process of segmenting the callus of an image, but I will not be describing the steps in detail. This is covered in the basic tutorial. One of the really cool features of OrthoRead is that as you navigate between images, OrthoRead will update the results field to reflect the results of the active image. OrthoRead also remembers the current step of callus segmentation the user is in, so the user can come back to an image and finish the process if necessary. Last, I would like to go through some of the utility tools OrthoRead is equipped with. These are tools which allow you to manipulate the image to aid in the process of callus segmentation. To use the zooming tools, you simply click the corresponding icon for the action you wish to take. The tool will then zoom in or out on the center of the image depending on which option you chose. The Move tool is a utility which will allow you to navigate the image in the case that you have zoomed in so that the image is larger than the window it's contained in. The Crop tool is a tool that allows you to crop into the region of interest which contains the callus and fracture. In the event that you didn't crop properly, you can use the Resize tool to go back to the original image. The Rotate tool is a tool which allows you to rotate the image to different angles. The View tool is an option which allows you to remove the outline over the callus and view the original image. The user can also manipulate the amount of callus that is detected by OrthoRead by using the plus and minus options. The Export option allows the user to export a report of the OrthoRead findings once the callus is segmented. These reports are saved in the same directory that the image was opened from. The first report is a PDF which contains the results of the findings as well as the final image. The second is a table of the findings. In the case that the user segments callus from multiple images within the same directory, the results are appended to the OrthoRead table report. The last extra feature of OrthoRead is a result showing whether or not the callus has bridged the cortices. This is displayed below the callus button once the callus has been segmented. Here, we have covered some of the more advanced features of OrthoRead. If you have any questions or comments, you can email us at ntm@boisestate.edu.